This training course content is brought to you by Daedalus Aerospace. For on-demand flight test training, please visit daedalusaero.space. This is flight test risk management in 15 minutes or less. First, let's show how flight test risk management doesn't work.
The contract threshold is Mach 10.
10 is supposed to be in 2 months. Today's test point is Mach 9. Mach 10? Let's give Mach 10.
Approaching high hypersonic. Windshield hot caution.
Surface temp rising.
Come on, sweetheart, just a little more. Just a little. Come on! Come on!
Risk management during flight tests is not just a wise thing to do. It's legally required if you're an aerospace manufacturer. You may recall there was an aircraft design called the Boeing 737 MAX, which faced a great deal of additional scrutiny by regulators after some mishaps very early in its product life cycle. One of the results of that additional scrutiny was that Congress passed the Aircraft Certification and Safety and Accountability Act in 2020. This bill directed U.S. aircraft and aerospace industry manufacturers to adopt safety management systems. Within a safety management system, one of the 4 pillars is safety risk management, and flight test risk management is how you implement the safety risk management component as you develop new aerospace products. When I say risk, what do you think of? Well, there are many different kinds of risk. Here are a few. Now, some of these you were probably thinking of, but others you might not have thought about. So where does this risk come from as we operate test aircraft? Now, one of the perspectives used in Air Force flight operations looking at operational risk contributors is the 5 M's: man, machine, mission, media, which is another way of saying weather and other outside factors, and management, which includes cultural aspects. Flight test risk management includes all these aspects, but is also quite different from regular flight operations. We can't approach flight tests in the same way as operational aviation because we're usually doing things that haven't been done before. This mindset of flight test risk management has a long history, all the way back to the pioneers of flight. In flying, I've learned that carelessness and overconfidence are usually far more dangerous than deliberately accepted risks. One of the original flight testers, Wilbur Wright, knew that developing new systems for flight wasn't a matter of luck or bravado. For a dry perspective that's a bit darker, let's hear from one of his contemporaries, the father of rotary wing flight, Igor Sikorsky. At that time, the chief engineer was almost always the chief test pilot as well. That had the fortunate result of eliminating poor engineering early in aviation. Ultimately, flight test risk management is built from systematic critical thinking on a foundation of system engineering. If you really understand the system, you will be able to invent solutions for problems you don't have a procedure for. Chuck knew that as a flight tester, he couldn't treat the system as a black box, but needed to understand how it worked. That's the first step in our flight test risk management process, which is shown here. We start with understanding the system and the test that we're going to be doing, and then we ask ourselves what could go wrong, why, and how bad could it be if it does go wrong. From there, we have the information we need to conduct a risk assessment. That allows us to develop mitigations and emergency procedures. After we're done with writing all that down, we have a third-party review before we go into testing. During test, we use something called test discipline during execution, and then we document our lessons learned. Now, this is common sense, what I'm showing here, but also these words have specific definitions in the context of flight test risk management. Now, a cause is a condition that results in a hazard. It's the source. It's anything that could lead to the presence of the hazard, and there can be more than one cause for each hazard. A hazard in the context of flight test is any real or potential condition, event, object, or circumstance which could lead to an unplanned or undesired effect or event, i.e., injury, illness, death to personnel, damage to equipment or property, loss of material, loss of function, or damage to the environment. The hazard is the threat of harm and is a precursor state to a mishap. A hazard is any condition that could foreseeably cause or contribute to an accident. Finally, an effect is the result of the hazard. It's the consequence, the outcome if the hazard is not controlled. The effect is what our test hazard analysis is trying to prevent. So let's show how the test hazard analysis is built. The key to flight test risk management is identifying hazards, because this is the point around which you're implementing different types of controls. It's a common error to misidentify the cause or effect as the actual hazard, which can lead to missed opportunities to either reduce the probability or mitigate the potential impacts. Identifying hazards is like telling a story. You can tell it forwards from cause to hazard to effect by asking, so what, after each step, or Ask why to work the story backwards from effect to hazard to cause. We identify potential hazards through a variety of resources, including literature search, professional societies like the Society of Experimental Test Pilots, the Society of Flight Test Engineers, the Flight Test Safety Committee, which is a combination of those two societies, and AIAA. NASA has some great work here as well, and the wisdom of experienced flight testers. Hazards are the inflection point. Multiple causes can lead to the same hazard, and depending on how things turn out, the same hazard can result in a range of effects. With a particular hazard identified, we determine a categorized or qualitative risk assessment based on the likelihood that any of these causes result in the hazard and the worst case effects are realized. It's important to note that this is explicitly not a quantitative estimate of various probabilities, but is only intended to categorize the risk of a given hazard as low, medium, or high. The two-dimensional risk matrix shown here is a typical way to depict this analysis. The next step is to work through the potential causes and effects in order to apply mitigations. So we apply mitigations targeted to potential causes in order to reduce the probability of the hazard ever being realized. This is like trying to protect a young child learning to ride a bicycle by putting training wheels on the bicycle. We also apply mitigations targeted to potential effects in order to reduce the severity, assuming that the hazard has already been realized. This is like trying to protect a young child learning to ride a bicycle by making sure they wear a helmet. Mitigations are pre-planned and verifiable preparations that serve to minimize either the causes or effects of a hazard, but they're not the same as emergency procedures, which are the actions that the test team would take upon realization that the hazard was realized. We also create underlying test safety processes called general test mitigations or general minimizing procedures. These are not specific to any one test or even a type of test, but are basically the standard operating procedures that a flight test team will document to ensure a standardized approach to test execution. These include things beyond the normal flight manual or Part 91 rules, but are not necessarily tied to a specific test, such as testing will be conducted in day, visual meteorological conditions. So all these pieces of our flight test risk management plan work together as a system. The next step is to document our plan, and that is usually shown as a test-specific hazard analysis, which looks like this. The test-specific hazard analysis example shown here is out of FAA Order 4040.26 and serves to document in a one-stop shopping format all the information we just worked through: the hazard, cause or causes, effect, maybe plural, and risk level shown in a 2D risk matrix, mitigations for that hazard, and emergency equipment or emergency procedures also tied to the analysis. Please note that flight test risk management is different from other tools in the safety practitioner's toolbox, such as failure mode effects analysis or functional hazard analysis. There's a lot more we could talk about here, but let's move on. Before I go, I'll leave you with 8 key principles. These are from FAA Order 4040.26, which is one of the best resources to guide flight test risk management. First, accept no unnecessary risks. If you don't recognize this video, ask someone from Gen X to explain Leroy Jenkins.
I think it's a pretty good plan. We should be able to pull it off this time. What do you think, Abdul? Can you give me a number crunch real quick?
Yeah, give me a sec. I'm coming up with 32.33, repeating of course, percentage of survival.
Oh, that's a lot better than we usually do.
Alright, chums up.
Ready, guys?
Let's do this. Leroy Jenkins!
Oh my god, he just ran in.
Save him! Oh, geez, stick to the plane!
Oh Jesus.
Go.
Second, reduce risks to an acceptable level. Flight test does not require a 0 level of risk, or even the minimum possible risk, but seeks an acceptable level of risk. Some mitigations take a while to plan, source, and implement. Flight test risk management should not be a last-minute endeavor. Just as we understand that flight test risk will not be 0, or even sometimes the minimum possible, it's important for your organization to clearly articulate who is the risk acceptance authority. Flight test risk management is not the same perspective as operational aviation. There are inherent risks in aviation, but these are handled by other systems and are not the domain of flight test risk management. Flight test risk management plans should not be the sole purview of the plan author or flight test team. It's important to have third-party review to prompt critical thinking. Flight test is a team sport, and there are many resources available to inform your risk management planning. Finally, flight test risk management shouldn't be rushed. By the time the system development is converging to a solution, there is often time pressure on flight test teams to move quickly. This pressure needs to be set aside during the risk assessment to carefully consider plans and mitigations. In closing, I really love this quote from Dwight Eisenhower. In preparing for battle, I have always found that plans are useless, but planning is indispensable. If you want to know more about flight test risk management, I teach a dedicated course on how to craft flight test risk management plans, flight test risk assessments, and test-specific hazard analyses. Visit Daedalus Aerospace on the web to register.